All right, so let's get started. So I've already introduced myself. As I mentioned, I'm Paul Dowman. The company's OKG, and we do a lot with GraphQL. We've been doing GraphQL stuff for about 3 years. That includes training, so we teach advanced and intro GraphQL training. But most of what we do is actually consulting. We help companies implement GraphQL in various ways, whether that's at the architecture level or actually implementing it or anything in between. We do that. So just before I get into talking about schema stitching, I want to just back up for a second and just remind ourselves why we use GraphQL. There's a lot of reasons, but one of the main things is like the performance thing. It's one network round trip. The client makes one request, and that's kind of a nice thing. It's not just nice for performance, it's also nice because it takes a lot of the logic away from the client. So if you're building with microservices and your client has to communicate to all of them, that could get super complex on the client. So the performance and the complexity. Of course, there's lots of other reasons. But with that in mind, let's talk about microservices. So I'm sure you're all aware of what they are, but the really important point is that they're back-end services that are developed and deployed independently. I would definitely look for this monolith first pattern. Martin Fowler has talked about this, where he says, in fact, it's probably worth even taking a really quick look at that, just because I don't want to be up here talking about microservices without I don't want to evangelize something that, anyway, it has its place. But this is really important. Martin Fowler says that he's noticed almost all the successful microservice stories have started with a monolith that got too big and was broken up. Almost all of the cases where they've heard of a system that was built as a microservice system from scratch ended up in serious trouble. So, with that in mind, let's get back to talking about microservices. So there are good reasons to build microservices, even if you don't start that way. And one of the reasons is that, especially in big companies, often they're organized around business capabilities. Like, the people that build one part of the system don't have the same budgets and the same people and the same anything as the other people that are building other important systems in the company. And the clients need to access parts from all of these. So when those are in a monolithic system, that can be like an organizational challenge, not to mention just a technical challenge. Of course, there's the freedom to use whatever tools and language and whatever that you like. Different teams can do different parts of it however they like. So these are good reasons to actually build microservices. So if you're using GraphQL, if all of your microservices are actually providing GraphQL APIs, then what does that look like? So here's an example, and I'm going to show a working application with this. I mentioned that we do training, so I pulled this out of our advanced training course. So I'll show you the app that we build in our training class, and this is a little part of it. We've got two separate services. So at one point in our advanced training, we do the schema stitching exercise. And what we do is we pull in weather from a separate weather service, and we pull it into our application. So we've got, but for now, just think of it as two services. So one is place, and places have a location, and a location has a latitude and longitude. And the other service, it just has weather. And the weather, although actually I neglected to show it here, there's a query for the weather that takes a latitude and longitude as parameters. This is just the type that I showed here. So let's take a look at these, what this actually looks like. So this is running locally. This is the place service, and let's do a query that looks like places, and then let's do. We need. Let's ask for an ID. an address, oops, and a location. And oh, location has to have some fields. Location is going to be a latitude, longitude. So this, is that legible? It's big enough? So this place service can return back places, and the latitude and the longitude we've like pre-populated the database with a few things in here. Now the other service that we've got is our weather service. This is just running on Code Sandbox, so it tends to shut down. So let's wait for it to start up. Okay, now this is the weather service. So we've got this query called weather. It takes something called coords, which is a latitude and a longitude, and then we're going to need to specify what fields we want back, which is going to be let's say icon, temperature. Okay, so 0, 0, wherever that is, somewhere on the equator. Right now, the temperature is 28 degrees. Sweet. Now, what we would like is if our places also had a weather attached to them. So it would be really cool if the location could have weather. If I could just do that, something like that, right? And then do latitude and longitude in here. I can't do that right now because weather comes from a totally different service. So we'll get into that in a second, and I'll show what our sample app looks like. So the sample app is actually let's do that. So our sample app is at localhost 3000, and I can list the places. So this is the app that we build in our training, and what you can do is you can add a new place, like New York. It's a bucket list app, whatever, just a silly, fun thing. But it would be cool if they had the weather on them, right? So we've got this weather service. It's built by somebody else. Now, I'm not necessarily recommending that you're going to pull in someone else's public API into your public API. That would probably be problematic for various management reasons, like they might just change stuff on you or whatever. But we're talking about internal teams in the same company. So let's move on. In microservices, you're going to have separate requests if the clients are requesting different microservices. The client does the joining work. And we've talked about those, but the other thing is services can start to grow overlapping functionality as well, right? That's also a management problem on the server side, because if you're the places team, maybe it's easier for you to just put in some weather functionality. And just things start to get, messy. So the Apollo people recently published this thing called Principled GraphQL. I recommend you take a look at it. But one of the things they said is your company should have one unified graph instead of multiple graphs created by each team. By graph, they mean schema. I would check this thing out. It's definitely, there's not a lot there, but it's good stuff. Another thing they said in there is that when teams create their own individual graphs without coordinating their work, it's all but inevitable that their graphs will begin to overlap, adding the same data to the graph in incompatible ways, etc. So they want to make sure that the ownership of certain entities in your schema is clearly owned by somebody. That's their recommendation. So one way that people often do this with microservices, this is not even a GraphQL thing, even with REST, is the API gateway pattern. So the API gateway pattern is basically one or more single entry points for all clients. You might not have one, you don't have to have just one monolithic API gateway. You can have more than one, but essentially it's having this one entry point where all the client requests go to, and then it makes out the backend requests to the microservices. Ideally, adding as little logic as possible. So it should be a dumb proxy, as close to a dumb proxy as possible. So this means the client can make one request and not have to do all that complexity. Sometimes this is known as the backend for front-end pattern, the BFF, which is where you have multiple different API gateways that are very specific to the needs of different types of clients. And yeah, I mentioned this, you don't want to have too much business logic in there. And here's another thing that they say in the principled GraphQL website. Though there's only one graph, the implementation of that graph should be federated across multiple teams. So this is again the part two of that point about not having it be one giant monolithic thing. Although opinions vary, and I'm going to give you a link at the end for one of the talks from GraphQL Day, where Marc-André Giroux talks about this, and he's done a lot of writing. And actually, he's writing a book on this that I would recommend reading if you're interested in this. And at GitHub, I do believe that they have a monolithic schema, and this is something that is like makes sense as depends on what organizationally makes sense in your company, or if you hit a point where the monolith is painful. So with the API gateway pattern, your backend services can be REST, gRPC, whatever, any kind of, or SOAP if that's your thing and you really want to do that for yourself, or GraphQL, of course. So if you have an API gateway that's serving GraphQL and you have backend services that are also GraphQL, can we simplify things so that you don't have to have resolvers in your API gateway that have to basically that just have to do a lot of lines of very repetitive code to call out to the backend services. So is there a way that you can sort of just delegate these things to the other backend services if they're also using GraphQL? Well, it turns out there is. There are other ways of doing this, and I'm not going to get into how this pattern could potentially be problematic, but this is the Apollo way of doing it, and it's done with some functions that are built into the GraphQL tools package. So if you don't know, the Apollo server, the node-based Apollo server is, well, it's built on this package called GraphQL tools, which is a lot of some generic tools to do with how your schema is put together, things like that. And there's there's several things, but the three really important things that we're going to use to put this together. So we've got this one called make remote executable schema, which basically, we'll see this in code in a second, so I'm just going to kind of gloss through this. But basically, the key that we're going to do is we're going to have the server be like a client to the other service that it wants to pull in and merge with itself. And it's going to use basically the same tools that you would actually use on a client. So if you're familiar with Apollo Link on the client side, it actually uses that. Then it does something to merge the schemas together. And we can write some code to delegate parts of our main overall schema, to delegate parts of that to the remote system. So let's see how that works. Oh yeah, and GraphQL has this extend keyword. So you can extend objects with this extend keyword, and we'll see this. So let's actually do a real quick little coding exercise here. So is that legible at the back? Large enough? All right. So I'm not going to bother typing everything. I'm just going to copy and paste some stuff because it will be quicker and with less screw-ups that way. So here we pull in make executable schema from GraphQL tools. So for those of you that are not familiar with the Apollo server in Node, what the code looks like, this is kind of like the core thing that you've got in every code, in every Node server that's putting together your resolvers and your schema. This is just part of your standard setup. So I'm going to paste in some things that we will use just require some things to be available. Let's not worry too much about it. We'll explore them as they come. And there's a whole bunch of other setup stuff that we really don't care about in here. So I just want to focus on this one thing. So we've got this make executable schema with type defs and resolvers. If you do a lot of maybe that's too big. If you do a lot of work with Apollo server, this is familiar to you. Otherwise, don't worry about it. This is where we give the schemas and resolvers to the Apollo server, essentially. Okay, so then I'm going to pull in this other setup, and I'm going to basically, let's just comment this out, and instead I'll just paste in these 3 chunks. So the first one is we make what's called an HTTP link. So if you're familiar with Apollo client, this is something that you've probably seen. This is the URL to our remote service. That's the same thing that we saw over here. That's this. This is our weather service. Okay, so we've got our something that's going to pull in our weather service using fetch, which is node fetch. So this is just going to make an HTTP request, and it's basically this is a GraphQL client pulling that in. Now we're going to take that link and we're going to give it to this introspect schema thing, which is going to look at it and basically parse it out, give it to this make remote executable schema, and then we end up with this remote schema. So now we do this function, this merge schemas thing, and don't worry about what these functions exactly are. You'll read it in the docs, you'll copy it from the docs one time, and this will be your setup. But I just want to kind of explain the overall concept here, which is this server here running on localhost at port 4000 is going to make a request out to the other server and merge those schemas together with this merge schemas thing here. So we've got the remote schema and the local schema. They are now merged together as one. Let's see what that looks like now on our client. If I go back to my localhost 4000, I'm going to have to refresh it so that it can pull in the updated schema. I should be able to do something like weather. So now, ta-da, I've got the weather API. We're not done, but I can actually take the same weather query that I had done to the weather service, and I can give that same query to my places service. Let's run it, and I get back the same thing. So that wasn't very useful. The places service is simply proxying this weather query over to the weather service. We have gained nothing because now we have, well, I mean, you know what? Actually, that's not true. There's a lot of cases where maybe all you want to do is have a couple of different root queries that you'll pull together. But in the real world, it's going to be a little bit more complicated than that. We don't want to just have weather at the top. Now, actually, this is actually functional. I could, in my client application here, do some work on the client to, for each of these different places, I know the lat long, I could make the weather query back to my same service, but I haven't really gained anything. I could make that weather query out to the weather service instead. So what I would really like is if this weather, instead of being a root level query, if weather could be a field underneath location. Something like, well, it's all commented out there, but I would like weather to be as a root level field. I shouldn't have to pass it coordinates because the lat and long are already on the object. So let's move towards that. So I can take the next step, and I'm going to do 2 things here. So I'm going to make a new local schema. Let's make some space in here. Paste that in. I'm making this new schema here that is just extending the location type and adding a new field on it. So this is the extend keyword that I mentioned before. this lets me just modify the location type. So I showed what location looked like previously, but basically it well, the location looks like that. Now we're adding weather onto it. So if I, let's see what else we're going to add. I'm going to do this in a couple of different couple of steps. I'm going to add in merge schemas. Now I'm going to add my third schema that I just created. I'm going to add this loop schema. Okay, so now I've merged three schemas together. So if I go back to my client and I refresh, I should see, if I look in here, I should see that my location my location type now has a weather field on it. But still not very useful because it doesn't work yet. Okay, so I'm going to take a couple of more things. So I'm going to add, I'm going to do this just so that I don't screw up my copy and paste thing. I've got so many levels of indentations. This is quite ugly, but let's see if I can not mess this up. I'm going to take the whole thing. Okay, so there's a few things. So I just pasted in a whole lot of stuff, and I did that because I would probably screw it up if I typed it all in. So let's get rid of a couple of the pieces. Basically what we've done is we've added some new resolvers into our, so now, just as a reminder, this is the server that is the places server. It's got our local schema, it's got the remote schema, and it's got this new little link schema that we've added. But so now we can add in some resolvers, and the resolvers look like, if you're familiar with what resolvers normally look like, they've got this thing called root, or sometimes it's called parent, args, context, and info. How many of you guys are server? How many are you familiar with the? Okay, not too many. Some. Okay, all right. For those of you that are not, this is just what the GraphQL resolver signature usually looks like. And basically, we're just creating one. We're creating a new resolver, and what we're doing is inside of it, we're using this thing called delegate to schema, and this is something that Apollo provides that lets you, well, it does what it says. It delegates the whatever this resolver is supposed to do, it will delegate it to your remote schema. So it takes some parameters. So we're going to say delegate it to remote schema. The operation is going to be a query. The field name is going to be weather, because that, if you remember, on the root, it's called weather. So that means run this thing. Okay, so we're adding a field called weather under location, and we're delegating it to the field called weather, which is the top level query on the remote schema, if that makes sense. And then we are giving it some arguments, because look, see this coords thing that takes lat and long? That's what our remote weather thing needs. So we're going to have to give it coords that are lat and long, and that's basically it. So we're basically saying let's take every time somebody requests the field called weather on the location object, let's call that root weather thing and give it lat and long. So what are lat and long? Well, they come from, this is actually parent dot, depending on your JavaScript skills, this is less confusing. It's basically parent dot latitude and, oops, let's not reverse them, longitude, and this would be parent dot latitude. So we're basically delegating them. Let's see if that works. I'm going to get rid of that and go back to this one. All right, I didn't break anything. The old thing still works. Now let's see if I can add weather. Actually, refresh just to make sure it's got the schema. So I can add weather. I should not need to give it any parameters. Remember, the root weather needed to have this arguments passed in. I should not need to. And I should be able to say, ask for all of its fields, ID, icon, temperature. Let's see if I broke it. Yeah, I didn't. Okay, cool. So there it is. So in San Francisco, the weather is cloudy, and the temperature is 12.8 degrees, even though they probably think it's like 65 degrees. The weather in Toronto is, is it raining outside? Okay, that's news. And it's 6 degrees. So there we go. That was it. There's one more little wrinkle, and I don't know, like if this, I'm not going to spend too much time on this one, but just in case if anyone is actually still following, you might find this interesting. And this is the kind of stuff we go into in our advanced class. But there's one little wrinkle. So I have this thing here, this fragment that we add. Now, why do we add that? Well, let's take it out for a second. Don't worry if this is over your head. I'm just going to throw this in real quick. If I take out lat and long from the query, so in other words, if this field is not looking for these, and I run it, all of a sudden I broke the weather, and actually location, let's add something else just so we can see that location is coming back. So the whole location is null in this case. Right, so I'm still getting back an ID, but the weather is null. So I just broke the weather. If I put lat and long back in the parent, all of a sudden my weather works again. This is obviously a problem. You don't want to have to tell your clients, oh yeah, by the way, if you're going to ask for weather, make sure you also put lat long in the location, and if you screwed it up, it's your fault. No, you don't want to do that. So what you do is we can add this fragment on the location, which is always going to make sure that the lat and long are present in the resolver. So if that didn't make sense, don't worry about it. If you want to, I can explain it afterwards, but this is some crazy stuff. Now, that is not highly readable. There is a lot of, you could argue this is quite tightly coupled in a lot of ways. So, make what you will of that. I'd be happy to talk about that kind of stuff at length afterwards or in another time. I just wanted to show how it works here. Not necessarily go into like the good and the bad of it, but I want you to be aware of that, right? So if you're writing microservices, where you've got like really decoupled things, when you're doing that, just think about like the way you want to put them together, depending on how coupled you want them to be at this, at the schema level. How often are you going to have to change these things? Just be aware that there is. This is not a dumb proxy at this point. Like we are writing resolvers here. We're doing a fair bit of stuff that could be brittle when other things break. There are other ways of sharing. There could be other ways of splitting up your having one schema from the client's perspective, but splitting it up from the back-end development perspective. Like you could do NPM modules and pull them into your API gateway. Again, that's got other problems. Like you have to, release a new version of your API gateway to change things. But anyway, that's out of the scope of what I want to talk about today. I think that might be it. Let's see what else I had. Oops. Oh yeah, so that sort of like architecture level, the issues with this and the other ways that you might want to do this. If you're interested in that, definitely, or in fact, if you're interested in any of this, definitely watch this talk. This is from GraphQL Day Toronto, which we did a couple weeks ago. This is Marc-Andre from GitHub. This is an awesome talk, and if you follow this link, I can share this afterwards if anyone wants as well, or just look for GraphQL Day Toronto videos on YouTube and watch. It's the first talk. It's the first one in that playlist. It's Marc-Andre from GitHub, and so he goes into this stuff in more depth. Okay, so while I have your attention, I just want to plug another conference that we're organizing, which is called Assert.js. We did this last year in the US, and this year we're bringing it to Canada, and it's a conference for JavaScript developers focused totally on testing. So if you're writing any JavaScript, client-side or Node or whatever, and you're into testing, or you're not into testing, and you should be, come to this, and this will be. I think last year was pretty awesome. And if you're interested, the talks are online as well for that last year. So we're doing that here in Toronto. It's going to be in September 12th at Mars. And check out assertjs.com for more info. And that's it. That's me on Twitter. And that's more about what we do with GraphQL. Cool. Thanks.